Hi, in this video we're going to consider angles of elevation and angles of depression and use that to solve a problem to find an unknown length using trigonometry. Now, what do we mean by angles of elevation and angles of depression? Well, suppose we had this plane on the left here and we kind of considered angles relative to the horizontal. Now, if we had some object here and we wanted to consider the angle of elevation, that means the angle you have to look up to from the horizontal until you're looking at the object. So this object here, if I draw a line to it, the angle of elevation would be this angle upwards like this. So this is an angle of elevation, the angle above the horizontal. And then you can possibly guess what the angle of depression is. If we considered looking from the plane towards this other object down here, then the angle of depression is the angle below the horizontal. So this angle here would be the angle of depression. Now let's use it to solve this problem here. The distance between the top of a tree and a point P. So let's draw the ground. We've got a tree, and the distance from the top of the tree to a point P on the ground. So we've got a point P on the ground here, and that distance is 13 meters. So let's draw that on. We've got this length here is 13 meters. I'm just going to assume the unit of meters. And the angle of depression is 39 degrees from the top of the tree to the point P. So that means you're at the top of the tree, you're looking down 39 degrees to look at the point P. So if we look from the horizontal like this, then this angle downwards here, that's going to be, what was it? It was 39 degrees, like that. Yep. Now we want to find the horizontal distance between the tree and the point P. So the horizontal distance will be this distance here. If I just highlight that, it's the horizontal distance between P and the tree going horizontally. So how do we do that? Well, firstly, note that we can find some of the angles in this triangle because the angle between this tree and the ground is 90 degrees. You presume the tree is upright. So that angle is 90 degrees. And we can also use something called alternate angles. Remember this kind of Z shape like this, where you have two parallel lines. You can see that this line is parallel to this line, and you get this Z shape. And remember, the angles in the Z are the same. So this angle here is alternate to this one. So this one is also 39 degrees here. Right, so we've got an angle of interest in this triangle here, the 39 degrees. And we've also got some lengths. We've got the 13 here, and we want to work out this horizontal distance. Now, we don't have a side length there, so just put x to be an unknown length. Now, we can just use trigonometry. Remember, we first label the sides relative to this angle of interest. So ignore the 90 degrees. This angle of interest is a 39. Now, we can see this 13 here, this side length. That is the hypotenuse of the triangle, the longest side length. So we put an H in a circle. And this side here, the x, is next to the 39 degrees. It's adjacent to, we say. So we label that with an A. So we're involving A and H. And then we use SOHCAHTOA to work out which trigonometric ratio we want to use. So SOHCAHTOA, well, we're involving A and H. We can see this one is the A and the H, this one here. So we're going to use C, which is cos, remember. So this is short for cos of the angle of interest is equal to the adjacent divided by the hypotenuse. So let's substitute in our side lengths and angles. We've got cos of the angle, which is 39 degrees. The angle of interest is the adjacent, which is x, over the hypotenuse, which is 13. Now, we want to get x on its own. We want to get rid of that over 13. So we multiply both sides of the equation by 13. And we get 13 cos of 39 degrees is equal to x. We just put that in our calculator. Don't worry about how your calculator works out cos of 39. And then we get x is equal to how many decimal places? 1 decimal place. So 10.1. And it was in meters. So it's 10.1 meters. That's the distance.